We're on?
We're on. Welcome back.
Take two.
Yeah, to simultaneous equations, part two.
Part two.
We're going to show you how. Last episode, we had started the same problem and we just rubbed it off there. But anyway, we showed you how we came up with, use these two and we made x equals 3, y equals 1. Look at part 1 if you want to figure out how we got to that.
And that's the point of intersection, isn't it?
So that's the point of intersection. So it's two lines crossing, but now we're going to rearrange to show you roughly
how to do it.
The gradient of the lines and where they intersect. So
Because back here we looked at
we know they cross there, but like, are they like this? Are they like this? You know?
how are they hanging?
Yeah.
Right, essentially. The top one we graphed because that was nice and easy. Y equals x take 2. And we kind of have to remember, Mr. Bishop, that the standard formula for our graphs is y equals mx plus b. And if you go on to connect, there's actually this old chestnut. Remember this old chestnut? There's this one here. Hopefully this is focusing properly. There's the Year 10 mini test, which was on linear graphing, which shows you how to, demonstrates to you, and there was another one we put up there also, how to graph a linear equation. Okay? But if we dive straight back to this one, we'll sort of say, well, this is the standard formula for linear, is y equals mx plus b, the plus b being the y-intercept.
So that is
this m.
The last number
Yep.
is where it crosses through the line.
Yes.
So it could be like that. If it's a negative number, it's going to be somewhere down here. Okay.
This number here.
Yeah.
This number on the end.
So that's what the y-intercept is, where it crosses through the y. It's self-explanatory, but
Yep.
yeah.
And -2 here means that this top one goes through -2.
Yeah.
And if we did that, it'd go through, as we started drawing before, that it went through -2 on the y-axis, right? And then we say, well, what's the gradient of this thing? How steep is it? What's the number that's in front of that x that's just implied? 1. So the gradient is 1. And if we say the gradient is 1, it's 1 over 1, which means you rise 1 and you run 1.
So if this was grid paper,
Yep.
and you get your squares, it'd be go up 1 and across 1.
Cross
So it'd
one.
be like that. Now, if it's a positive number, by the way,
Like that.
I like to say positive numbers, if you read left to right, like a Harry Potter book, if it's a positive number, it goes up. If it's a negative number, it goes down. Various amounts, depending on the number that comes after
In
it.
front.
Yeah.
If it were -1, it'd go down 1, across 1, down 1, across 1. Because it's positive 1, it goes up 1, across 1, up 1, across 1.
Yep.
Okay, awesome. So the gradient in the top one is 1, rise 1, run 1, cuts through the y-axis -2, and it runs up 1, across 1. So and this is pretty rudimentary because we're just not using graph paper.
Yep, so
But it will go up on a 45-degree angle, in fact, straight through, because it's rise 1, run 1, because of the 1 in front.
yep.
Okay? Now the other one, the one that's more complex, is this next one, and we have to do some rearranging, Mr. Bishop. So I'll rub that out.
Yep.
Yep. Because we want to get it into the y equals mx plus b format. Where's the bell? Oh, that's okay.
It's recess.
Recess. Oh, no, we'll stay. It's
Yeah,
okay.
just for you.
Just for you guys. So we might rearrange this and we'll say 4x plus 5y equals 17. So what will we do there, Mr. Bishop, do you reckon?
I'll get it in the right order.
Yeah.
So as what you can go through it. We've got here it is, y equals mx plus b. So we have the y on this side, everything else has to be on the right side. Okay, so y, right spot.
Yep.
Yes, he is. 17 is right spot.
Yeah, 17's good. He's cooking with
But
gas.
the x obviously has to
Has to come over.
jump. Positive 4x has to jump.
And when it jumps the Mexican border, what happens to it?
Comes the opposite, so it'd be negative 4x.
Ah. Okay.
Yep.
Right, negative 4x plus 17. Is that cool though, to leave it like 5y?
I mean, it's right, but no,
It's
it's
right.
not. It could be simplified. Yeah.
Because we need to get into this format so you can graph it. Very hard to graph that
Yeah.
with the 5 in front of it. So what will we do with the 5 in front of it? What are we going to do with this guy?
Divide.
Divide. and divide by what?
5.
So we divide this side by 5,
Yeah.
and then we remove the 5 from in front of there.
Yeah.
So if we rewrote this formula in that sort of format, we'd have y equals minus 4 over 5x plus 17 on 5. Would that be right?
Yeah.
Yeah. And then what? So minus 4/5 means it's nearly minus 1, but not quite minus 1. It's like minus 0.8.
80%, isn't it?
80%.
Yeah.
So it's not quite as steep as a normal one, it's shallower.
Yeah.
And it's negative, so it's running kind of that way. And then 17 over 5, what does 17, 5 goes into 17 how many times?
3.
Okay, so I'll just plus 3, and how many left over? 2/5. 3 and 2/5. The other way of thinking about this equation here is, if you don't like fractions, because fractions do your head in,
Yeah.
is to think about it in decimals, if that helps you. So the decimal way would be y equals minus 0.8x plus 3.4. It's the same.
Or just remember, it's always, your x is always rise
Yes, that's the other way of
over
thinking about
run. Okay, so you can look at this and go negative 4/5. Now we don't have graph paper. I really wish we did, but your negative, the bottom number is how far I go across. So if that's 2, 3, 4, 5. So I go across 5 because that's the run, and being negative, I'm then going to go down
4.
2, 3, 4. So I have a dot there.
But we have to think about
But well, that depends on where you start from.
Yeah.
It's the
So
y-intercept.
So I'd always have a look at the y-intercept, which is 3 and 2/5, or 3.4.
Yeah.
Where would that be on there, Mr. Bishop, on that Cartesian plane,
Positive.
roughly?
1, 2, 3, 4.
4, and it's
Basically just under 4, 3.5, ain't it?
yeah, around 3.5, just under
Yeah.
3.5. Yep, because
So
it's a
that's-
sketch. So
I
we're
know.
not- Yep.
Yeah, going through there.
And as Mr. Bishop's rightly saying, if we convert it to a decimal, we're actually kind of making it harder, because you've got this in the rise over run format. People are
Yeah.
afraid of fractions and linear equations, but it actually gives it to you in the right format.
Mm.
All right, because the equation's there, so you go down 4 across 5.
So let's go across 5. We know this
Yep, we know that's
from
the point.
that. We know that is
There,
the
that's
intercept.
the y-intercept.
And then I'm going to go across 5, which is, I've got 1, 2, 3, 4, 5. So I'm up here at this point, and then I'm going down
Down 4.
4. Now I'm at almost 3.5. So
Yeah,
I'm going to pretty much go just below.
just below 0,
Yeah.
minus 0.4
Yeah,
or
yeah.
something. Yeah.
And then
Because you've
accuracy is not too great here, but oops, missed it. But
But the point of intersection
yeah,
is y is 1, x is 3, y is 1. 3, 1.
yeah.
X is 3, 1, 2, 3, y is 1. That's the point of intersection. So that kind of explains why we do the math.
Well, that was
to work out the point of intersection.
Yeah, that worked out perfect, really. But
Yeah.
3 and 1 on a dodgy graph there.
If you had graph paper, and we have put a graph paper PDF up there if you'd like to print it out, you can click on it. I think Mr. Wallace whacked it up there on the Year 10 Connect page, but you can print off graph paper if you'd like it.
Yep.
The other thing to do is just, the accuracy is not important so much, it's more that you understand where this would fall in the Cartesian plane and where the point of intersection would be. And understanding the math, of course, is quite important, but the accuracy factor is not important here today. Okay?
Yep.
With that,
It's a tough one. Maybe we'll do another example. Ask us questions. Don't be afraid to
Yep.
ask questions and show your face on
yes.
WebEx.
So we'll do
So this is part 2. Yeah.
we'll do a WebEx Thursday.
Yeah, I might do one of these on maybe just on graph paper, like with the overhead camera.
Yes, that's a good one.
possibly.
We do the overhead camera. Okay.
Yeah.
But ask us questions on Connect. If you don't understand something, ask us a question and we'll create a YouTube video. Davies, Bish Dog, please create a YouTube video on whatever it is.
We'll even
and
give you
create
credit
it.
if you want. You can put your
Yeah.
name up.
Excellent.
Just gonna
We
be-
can say that it was, yeah.
All right, when you get
Thank
back to school, we'll give you vouchers.
See you guys.
See ya.